Alright, this video is going to be on Wolff Kishner reactions. The first half should look familiar, the second half, not at all. But there is a trend to the second half. So long as we know what our product should look like, it should help us guide our reaction. So with Wolff Kishner, we first need to make an imine, okay? So I have, just say ketone. To make an imine, I can use NH3 or you can use a primary amine. Mildly acidic conditions. Okay. It works the same as an imine. Okay. Wolff Kishner is this weird kind of amine here. So we're going to make an imine out of this amine, which these are both, it's two primary, but it's going to work the same way. Wolff Kishner just means we need to do this is our imine, and then we'll do some stuff at the end there as well. I asked Dr. Andrews about this. It wasn't very clear in the book. The proton source for this, when we usually do this, we use the protonated version and the deprotonated version, but using a nitrogen compound like this, it's not really going to want to give up protons. It's pretty basic. So we also have ethylene glycol with this, which if you should be familiar with. This is what we use to make cyclic acetyl groups, but in this case, it's just going to be our proton source. Okay, so a couple things are changing here, but it's a typical imine reaction: formation, condensation. I have my primary amine, and this is going to be my proton source. That's the only thing that's different. So let's go through this here. I'm mildly acidic, so I'm not going to activate my carbonyl site. I'm going to attack right away. So lone pair on nitrogen attacking my carbonyl group. O minus. Here I have NH2, NH2 plus, and then another carbon. Okay. What's going to add a proton onto our oxygen? Ethylene glycol. So proton transfer there, and we'll get OH. What's going to take a proton off of my nitrogen here? Ethylene glycol. Okay. Maybe even that O minus there. The fact that she didn't have this listed, yeah, it's not too important. I would actually just use this. We're mildly acidic, so let's actually draw this out. So just skipping over it, it'd be easier for me as well. We got O minus there. We're mildly acidic, okay? So I'm going to say that there is, this is protonated already. Okay. Proton transfer here, okay? And then we have this structure here. We need to get rid of a proton. We would do that there. And we'll be left with this. Just two proton transfers there, and I'm using the protonated version here and the neutral version because we're in acidic conditions. Okay. All right, same imine kind of reaction as before. I should be familiar with acetals, imines, and enamines when I'm forming them. Okay, boom, it should be familiar by now. We have to make that water, and we'll kick it off. So how are we going to protonate water? We'll use our protonated version of our ethylene glycol. It will become water. And how are we going to kick it off? Double bond, which makes sense because we want to make an imine. So combining a couple steps there. Water leaves, double bond to nitrogen. Like that. Positive charge there, okay? And then to take that hydrogen off, I would use regular old ethylene glycol, protonate ethylene glycol, deprotonate this molecule here, or this nitrogen here, deprotonate the nitrogen, and I'll be left with our imine, okay? Imine because we have a nitrogen carbon double bond, and because we used our Wolff Kishner reagent, we have now this structure here. At the end of Wolff Kishner, okay, by the very end, we should have a nitrogen-nitrogen triple bond. All right. It's Wolff Kishner reduction as well. So at the very end, we need to get as many hydrogen bonds here, basically take our heteroatoms off. The most reduced we can be is a carbon chain. So we want to be as reduced as possible. So I have our carbon chain there, and we want to make a triple bond between these two nitrogens. That's the goal. That's the goal. So the reaction steps to reach that goal should be making bonds here and taking bonds away from here, okay? We want a nitrogen-nitrogen triple bond, and we want to have these separate. So let's work right to left here. And I'm going to move this, yeah. Let's keep working with this. So up until now, this is our imine reaction. With Wolff Kishner reduction, I'm going to work pretty much top to bottom. I'm going to work top to bottom. I'm going to take hydrogens off here. These bonds are what's going to form our triple bond. And then I'm going to take electrons here and form enolate ions, anions. Okay. This is where it's kind of get into memorization for the most part, which is unfortunate. Up until this, it's been pretty consistent with what we've been doing. But now we're going to work top to bottom, and we're going to try and get bonds here and remove bonds between nitrogen and carbon. Our first step, and they are probably, they must be in different, I think, reaction conditions, because our first step involves OH minus. So I can see maybe this being the first step of our reaction, and we take this, and now we're in slightly basic conditions. At least we have OH minus. It just has to be memorized. OH minus, proton acceptors. What's our most acidic proton? Cardio rules tells us that would be our protons on nitrogen. And this here goes on to nitrogen. That's going to be my first step. Okay. Charge there. And oh, I'm the wrong nitrogen. Oh no. There we go. Okay. I now have negative charge on the nitrogen. My final goal, I want to make a triple bond here, and I want to get rid of these bonds. I want to make a triple bond here. Let's move our electrons there to make at least a double bond. And then that's going to move this double bond and form an enolate ion. Yes. Yep, I did that right. So I'm moving top to bottom. I move my hydrogen off top, moved on to nitrogen. And I'm just work my way down. Nitrogen now, double bond, and enolate anion. So top to bottom, hydrogen on the nitrogen. I'm working to make bonds here, and I want an enolate anion. Nitrogen double bond, I have my enolate right here. Negative charge, nucleophilic attack. What are we going to attack? The water we created over here. Remember, we want to be as reduced as possible. That means we have carbon-hydrogen chains. I'm taking this double bond, I'm turning it into just a hydrogen. I want as many hydrogen bonds as I can. So lone pair on our enolate is going to attack water and become reduced. One group here, nitrogen, hydrogen, and then there's the little hydrogen I put on. Good. Okay. Perfect. Perfect. I'm going to work top to bottom again. I have hydrogen up here, which that bond can be used to make a triple bond, enolate, reduced, I'm done. So same as before. What am I going to do to deprotonate? OH minus. Take the proton off. And that is going to go directly. It won't go on the nitrogen this time. This is kind of funky. That's why the bond here. I'm going to attack hydrogen. This bond is going to go straight onto the triple bond, which moves this one to make another enolate anion. So whereas our first step, we went top to bottom, we went hydrogen directly onto the nitrogen, and then we made our enolate. This is kind of all in one step. We have hydrogen, triple bond, enolate. It's confusing, go back and try it. You could actually make your own problem, just change a couple things around. You could really only change your carbonyl, but it's good practice. So yeah, some memorization in this. All right, I'm taking this hydrogen off. Okay. I'm forming a triple bond. So I should, okay, OH minus plus H, that's H2O. Awesome. I got rid of my hydrogen there. I'm forming a triple bond between nitrogens here, and they're leaving. So that's good, we should expect that. And then we have our final product, almost, our enolate, which will attack another hydrogen off of H2O. Become protonated, and we will just get propane as our major organic product. So we went all the way from a ketone and all of this just to take that ketone off. Wolff Kishner reduction. We did, just to summarize, all of these steps are just imine formation, which we're used to. Okay, we had ethylene glycol as our proton source, something we'll have to remember. And I think to have these two structures paired, I think helps. Just they look pretty similar. Once we got to this point, we worked top to bottom to make our Wolff Kishner reduction. Reduction meaning I want as many hydrogen bonds as I can. And the most reduced carbon thing I can get is a carbon chain that's fully saturated with hydrogens, no double bonds or anything. So my goal should be to make this, take bonds away from our ketone, our double bond, take those bonds away and add bonds to nitrogen. That needs to be our goal when doing Wolff Kishner. And I work top to bottom. And I work my way down to make an enolate. I did the same thing over here. top to bottom to make an enolate. It's confusing. I'd be impressed if you got it the first try. I would go back, write only this down, try it on your own. Maybe you get it, maybe you don't, and then you can make your own problems with it. Just change your ketone around, make it an aldehyde, add some carbons on, and try it with classmate. One more video on nitriles for now, and then aldols will probably come sometime tomorrow if I have motivation. So, good luck with all that.